Hello, we're going to talk today about section 4.4, which is on the laws of logarithms. Okay, so in this section we're going to be dealing with the laws that will help us work and maneuver a little bit quicker through with the logarithms. There are three laws that we'll be discussing. The first one is if you have two things that are multiplied together, multiplication can be split up by adding. So, for instance, if you know what individual pieces are, but you don't know what A and the B is individually, by multiplying them, you can split them and then into addition. Conversely enough, it works the same the other way. So if you have it as adding and not knowing them individually, then you can bring them together to multiply the two pieces together. One thing I hope you guys realize is the bases are the same, and the bases will all be the same. Also, this A and this A are not the same. Lowercase a and uppercase A are not the same things. A lot of people get that backwards or think that that's happening because of the fact that because you have that or whatever, but no, it's those two are not the same. Uppercase and lowercase are not going to be the same thing. The second law is, what if you're dividing the two pieces? Dividing the two pieces, if multiplication was the same as adding, dividing is going to be the same as subtraction. Okay, so those are the first two laws. And the third one deals with exponents. So if you have log base A and then A to the C like this, then what happens is you put the exponent to the front and multiply it by whatever it is. Those are the three laws. Okay. If you're interested, there's proof of these as far as how to and where they came up with them, but I'm not going to prove them. I'm just going to give them to you and then see how and show you how they're used. But there is proofs out there if you want to go look them up. They'll show you exactly how they prove that works. But for our purposes, we're just going to give you the three laws and then show you how we're going to use them. So first types of problems are going to do something like this. We're going to have log base 4 2 plus log base 4 32. Now, recalling from last section, if we want to rewrite this as exponentials, this particular one right here would be 4 to the x equals 2, and this would be 4 to the x equals 32, and I'd have a plus sign in between whatever the x's are and all that kind of stuff. And looking at that, that's kind of a big mess because we got adding and we got equal signs in there all over the place. The other thing is I can't write 32 as 4 to the something. I can't write 2 as 4 to the somethings. So those particular things, we're not going to rewrite those. Not yet anyway. Okay? That's just a little bit too much work. So adding, recall from the last slide, adding is going to be the same as multiplication. So what I'm going to do is I'm going to condense that by simply taking, notice the bases are the same, 2 times 32. 2 times 32 is 64. So now what my goal is I'm trying to figure out what is the log base for 64. I'm trying to evaluate it. Remember those ones from last section where we set it equal to x and we're trying to figure out what is x equal? Well, now if I rewrite that, 4 to the x equals 64, 64 is 4 to the third. So now, if the bases are the same, then the exponents would be the same, so x equals 3. I couldn't do it individually, but together I could make it work. Okay, I could not make the log base 4.2 and log base 4.32 work on their own, but together I could make them equal the number 3. Another one, just kind of give you an example. And again, same kind of concept. What what can I make 2 to the what power makes 80 does not exist without being decimals and stuff. 2 to the what power equals 5, not going to happen. But subtraction is the same as division. So as long as my bases are the same, which they will be in this section, 80 divided by 5. 80 divided by 5 is 16. And again, my job is trying to figure out what x equals or what the evaluation is. Well, if I rewrite that as 2 to the x equals 16, 16 is the same as 2 to the 4th. And if the bases are the same, then the exponents should be the same, and my answer is x equals 4. So, just so you know, that's kind of those, or how we're going to write those or use those laws in order to rewrite them so that we can use that stuff we learned in section 3 and then solve my problems. The next thing that they're going to do is they're going to say use the laws to expand it. Okay? Expand means make it bigger. Okay, I kind of equate it to, and usually when I'm teaching this section, it's usually close to a holiday. So it's usually right around like Easter time, or it's around Thanksgiving. So I say, well, what happens when you eat too much, you expand, you know, that type of thing. 4th of July, you know, too many burgers and hot dogs, I guess. But expanding means we're just going to take that multiplication, that exponent, that division, and we're going to write adding, subtracting, or we're going to have the number in the front. First thing is with this one, a lot of people mess this one up because they don't realize that that's 6 times x, not just 6x, it's 6 times x is how you could say that. Multiplication is the same as adding. So log base 2 6 is one piece, plus log base 2 x is the second piece. There is no more exponents, there's no more multiplication, there's no more division. That has been expanded. If I give you another one, this time with letters, a lot of people are more apt to seeing that that's multiplication between the two letters because the letters are obviously different. You've got x and you've got y. So multiplication first is the same as addition. Oops, I forgot my base number. Plus log base 5 y to the 6th. Then what I do is I get rid of my multiplication and division first. Then I move my exponents to the front because I don't want to move the 3 to the front now because not both of them are 3. Both of them are, one's a 3, one's a 6. So I'm not going to move the exponents until I get all the way done. So that's going to move to the front. That's going to move to the front. So I have 3 log base 5x plus 6 log base 5y. And that's expanded. Okay? So just so that you know, when we're expanding, we're just basically writing it out with a series of adding, subtractings, and then the number goes to the front. Let me give you one more. This one deals more with has a little bit of both. Actually, all 3 of them will show up in this one. So I've got the natural log, or the ln, of a times b divided by the cube root of c. So first thing is, I always like to get rid of my division first. I think it's easier to get rid of the division first than it is the multiplication. So division is the same as subtraction. Then from here, I'm going to get rid of the multiplication. So I'm going to split it up as ln of a plus the ln of b. Now I said there was going to be exponents in here, and if at first glance when you look at it, go, there's not exponents there at all. But a lot of people forget that this part right here actually can be rewritten as a fractional exponent. That's the same as the ln of c to the 1/3. Anytime you have a number here in the crack of the radical, that's the number that goes in the bottom of the fraction. If you were to have anything here, that would go up on the top of the fraction. So really that's saying the ln of a plus the ln of b minus the ln of c to the third can't have exponents. So the third needs to go to the front. So I finish with the ln of a plus the ln of b minus 1/3 the ln of c. That's expanded. So when they're asking you to expand it, that's as far as you can go. There isn't going to be anything else hidden in there. Typically you're going to see some radical symbols where you might have to rewrite it as fractional exponents. But a lot of times there can only be so many multiplications and so many divisions in there. So any division one, whether it comes from the bottom or if it comes from the bottom, needs to have a minus in front of it. Any multiplication, so a number on the top, needs to have an adding in front of it, and then any exponent needs to go to the front. Now the other way that they're going to treat this stuff is, now what if they give it to you all done out? This has been expanded. Now what they want you to do is combine it or condense it down into one single logarithm. Right now I got 2 logs in there. So when I'm rewriting it backwards, I try to, let's say I'm going to get rid of my exponents first. So this number is going to go back up to the x. This number is going to go back up there. So I have log x to the third plus log. It's important that you put this in parentheses also, because it's 1/2 to the whole thing, not to individual pieces. Because it's not saying x times 1, it's saying x plus 1. So it's important that you still keep it in the parentheses, because it's going to the whole thing and not just individual pieces. Nor can you multiply that all out, because it's adding in between there. There's no such thing as a power to a sum. Okay, so it goes to each piece only when it's power to a product, but not in this case because it's power to a sum. So this log x to the third times, and the reason why I'm timesing it is because multiplication is the same as adding, okay, and vice versa. Now that's an acceptable way to leave the answer. Another alternative, and depending on your instructor, would be if you were to put it like this. And the reason for that is because this half power, half is the same as square root, because we would put a 2 in there, but that doesn't do anything other than, that's the understood number there. So either way, those should be acceptable. Depending on your instructor and what they would prefer you to write, they are interchangeable. I'll give you one more like that. Now one thing that I always tell my students is that sometimes I write a cursive L and sometimes I write a non-cursive L. It doesn't really matter to me. And sometimes I uppercase it and sometimes I lowercase it. That's not an issue. They're all the same. So first thing that I do, again, is I use law number 3 and I put those back up into the exponents. So here I've got the ln of s to the third plus the ln of the square root of t. I'm electing to write that instead of writing t to the 1/2 as the square root this time, minus the ln of t squared plus 1 to the 4th power. And again, do not distribute that 4 into each of those because it is power to a sum. No such thing as that. So now from the rest of this, now just take it one step at a time. We're just going to go left to right. Adding is the same as multiplying. So I've got the ln of s cubed square root of t minus the ln of t squared plus 1 to the 4th power. And again, I'm going left to right. I'm going very methodical. I know some of my students are able to go, once they get the exponents back up there, they're able to just go from this step here right down to the answer. And that's fine too. Just be careful. Take your time. Go slow. Don't miss any signs. Don't miss any adding or subtractings, and you'll do just fine. S to the third square root of t, and then all this stuff goes in the bottom because it was, in fact, subtracting. Okay, so what I did is I took it from this expanded thing, very long, down into a short little nice itty bitty sentence. So that's what they're asking you to do when it talks about expansion or condensing. This would be an example again of condensing because you're getting it down to one logarithm rather than having two, or natural logarithm in this case. The last thing that we have in our section 4 is we have the change of base formula. What the change of base formula does, especially with calculators, is it allows us to use our calculators to find out the answer. If you notice, I didn't write a base number in this part. If there's no number in the base, it's automatically understood to be base 10, which means I can plug it in my calculator and find out what it is. So for instance, if I'm giving you log base 8, 5, which according to the last section, if we tried to find out what x is and we wrote that as 8 to the x equals 5, well, I'm sorry, but there's no way I'm going to write it as 5 to the something's not going to equal 8. Okay, unless I know a little bit about decimals. Those numbers are pretty hard to find. So instead of using that, all we're going to do is we're going to take log of the big number, is what I like to call it, divided by log of the base number. Simply put, you type log, which is on your calculator, it's the fourth one on the left from the bottom, and it'll automatically give you a parenthesis. You close it out, and you type log, automatic parenthesis, 8, close it out, and it'll give you an answer. And this one should be 0.774 if I round to 3 decimal places. Whatever your book says to round it to, or your teacher tells you to round it to, that's what I would do. So, just so that you are aware of it, that's what the change of base formula is. The other thing that's going to allow you to do is remember those ones that where we said, hey, I want you to graph log base 6 to the x, but again, you can't use your calculator. Well, guess what? Now you can. So if you want to put that in your calculator, you'd hit the y equals button. Then in your y1, you'd type log, an automatic parenthesis. You type the x, close it, divided by log, automatic parenthesis, 6, close it, and all of a sudden it gives you this looking graph. Okay, so you would have something like this, and it does something like that. Okay, now this down here, just so that you guys know, this actually does not just start in the middle of nowhere. That's what your calculator is programmed to do. It's kind of deceiving in a sense where when you're trying to graph it like that, that it looks like it just starts in the middle of nowhere, but it really doesn't. It goes on forever down. I don't know why the calculator does that, why it doesn't go all the way down, but it just doesn't. So when you're looking at that, just be careful. Know that it's really goes on forever down to all the way to negative infinity, but your calculator for whatever reason will not actually go all the way down there. So, but anyway, that's section 4.